Okay, now let's talk about calculating distance on a velocity time graph. So on a velocity time graph, on a VT graph. If you're given a velocity time graph, you can actually calculate the distance traveled. The distance is the area under a velocity time graph. So it's the area under a velocity time graph. So it depends what your graph looks like, right? Our first graph looked like something like this, right? You can have other graphs with different shapes. Just use different colors there. Maybe something like this. Whatever it is, the area here, the area of this shape and the area of that shape, that's what your distance is. Your distance is the area of the shape of that graph there. If you are able to calculate area of that shape, you are able to find distance traveled. So now let's go back to this velocity time graph that we used earlier on, and we want to find the distance traveled here. Now, there are different ways of doing this, right? You can divide this shape, right? So you might not be able to find a shape that corresponds to this entire graph. So you can divide this into different shapes, right? I can cut it and have a triangle, shape A, shape B, shape C. So I have a triangle, a rectangle, and a triangle. And then I'll find areas of A, right? And find area of B, find area of C, add it up. When I add up those areas, I'll find the distance traveled. But fortunately for me, in this case, this velocity time graph so happens to take the shape of a trapezium. Now, if you know a trapezium will have a pair of parallel sides. So this side and that side will be parallel. So for a trapezium, the parallel sides are called A and B, and the perpendicular distance between them is called H, right? And the area of a trapezium is half of A plus B times H, right? So fortunately, in this case, this entire graph here takes the shape of a trapezium. Now remember, we're looking for the distance traveled. So the trapezium must have the side A, side B, and the height. So first of all, we want to know the length of side A. Side A starts at 4 and goes up to 10. So this is 6, right? From there to there. That's 6 from 4 to 10. And then side B from there to there is going to be 16, right? Because it's the whole thing from there to there, that's 16. And then the perpendicular height H is going to be 24 because we're moving from there to there, that's 24. So if I plug that in, right, my distance is going to be half of A plus B times H. I'm using the area of a trapezium, which is half of 6 plus 16 times 24. This is what I was, these figures that I got here earlier on. So it's going to be half of 6 plus 16 times 24. So it's going to be half of 6 plus 16 is going to give you 22, right? Then you're going to have your 24. So half of 22 there is going to be 11 times your 24, which is going to give you your 262 meters. So that is the distance traveled. So that is the distance traveled for the whole journey there. Okay, now that you found the distance traveled, you can also calculate the average speed. So let me just clear this up and just leave my distance, right? My distance is 262. I clear everything else up. We can calculate average speed. We know that average speed is equal to total distance over total time. Now we now know our total distance is 262 meters, right? From our calculation. Our total time is 16, right? Seconds. 16 seconds. So our average speed is going to be 16 into that. So what do we get? 16 into that is going to be 1, and it's going to give us a remainder of what? So it's going to be it's going to be 6, 6,2 meters. Yeah, so that's something like that. 16.2 meters per second. That's going to be our average speed for the whole journey. So we found our distance, and then we found our average speed for the whole journey. So you can easily do that in the exam.